What's up, everybody? Welcome back to another episode of this mini-series about diffuse architectural overview. In this episode, we're going to cover Pitreos, an often overlooked piece of software that is magnificent. In this episode, we cover Pitreos. Pitreos stands for point-in-time recovery for EOS. Pitreos. The genesis story of that piece of software goes back to when we were producing on EOS mainnet at the beginning. We were looking for efficient backup and recovery solution because we had a producing node. We wanted to make sure it was really reliable, and we looked at all the solutions out there. Name it, we've checked it: tar, rsync, restic. We've looked at 75 of those. But we noticed two things that are very particular about EOS's largest files, namely the state and the blocks log, is that the state is a sparse file. And on EOS, we had provisioned 68 gigs of such a file. And if we look here on the terminal, here we have sample data from mainnet, right? If we look at what's effectively on disk, it looks like we have 8.6 gig. But if we look at what's inside the state, the shared memory here is 63 gigs, which is surprising. But this uses the sparse file feature of most modern file systems have that. It's a feature of the file system that says, okay, you have continuous data, but at this point, from that byte to that other byte, it's a given, we know it's all zeros. So we don't need to use actual disk space to store huge amounts of zeros. It's just a feature, you just sort of pierce a hole in that file. But if you don't have a tool that is aware that these are sparse and that this is a whole, what you'll see is you'll stream a big file and you're gonna have millions and millions of zeros, of worthless zeros. But if your tool is aware that these are sparse files, you can analyze and have different system calls to go and figure out where are the holes, then you can be very much efficient. And another thing, the second aspect of Node.js's largest files is the append-only nature of block logs, which is great. Other blockchain users normally level DB. It's very difficult to diff, very difficult to have as an append-only. It doesn't work like that. But block logs, thankfully, are append-only. You can take that assumption with certain checks, right? So when you have a block log and you make a backup and then you continue working and you do another backup, well, it's similar to this here, right? This is the first file, and these are chunks of 50 megs. These are the default chunking that we use in the default setting. You can change that or whatever. 50 megs, and then another chunk, and at some point you end a file, it's partial 50 megs. But then if you continue on, what you can do there is you don't need to verify. You can assume this was truncated here, and then you rewrite just that last chunk, this one plus another incomplete 50 megs, and there you go. So when you do a restore using Pitreos, you're actually going to fetch a previous backup, look at the state of the previous thing, look at what you needed to back up, and just assume these are the same chunks. And let's take a look at what it would like if you do a backup, right? If we go to the terminal again, I'm in the data folder here of the node, and I run Pitreos, and Pitreos has a few commands: backups. You can list files, you can list the backups themselves, the version, and then restore. So let's try here for backup. What you would see, you can add a tag, add some metadata. It's going to be stored like something like that, the block num, whatever, for programmatic. This is offered as a standalone command line tool, works very well, but you can also have it as a library, and actually this is all bolted in ManageEOS and the mind reader. For those who listened to the previous videos, this is actually exposed as a REST call, so you can do backups and recoveries. It's going to use that method under the hood without going through the command line tool, so as a Go library. So if we look here, you can do data, and by default, it's going to store that on the local file system at this location. Mind you, this uses the dstore abstraction, so we have support in there for Amazon, GCP, Azure, blob storage, local file systems, and it also supports local caching. So you'd have another directory where you avoid going and reaching out for files on the network. If you have a local caching, you're often doing some backups. So for example, a state you want to restore fast to the previous state. Well, you have all the chunks locally. It'll just go and write them back. We'll see how that works. So if I do a backup of this directory, I would just say dot. It's going to use those default values, store that in this directory here, and let's try that. So I'm going to time that, right? And we'll do some magic to shorten the time space. Bam. Okay, mind you, so it took 15 seconds to do a backup of something I did already before, But, and mind you, this is on my local NVMe disk. It's pretty fast. There's no network round trips. But it still went through and it looked at the previous backup, noticed that there's no need for the block log. It's a very tiny block log I have there. But it went through the whole state file, looked like 68 gigs or whatever gigs, and it just needed to back up those chunks. Were already written, so it didn't need to upload. So 15 seconds to do a backup. This is very, so on production for mainnet, we probably take a minute or so. And for a restore, let's try that, what it looked like if I want to do a restore. Now I want to do, I'm going to list, so Pitreos list. I want to recover for this one, restore here in this directory, and then let's see how long this takes, and let's do the same trick. And okay, 14 seconds to do restoration. Previous run took 13, 15, 16, around this time. So it's extremely fast, and because it knows and is optimized for those two special cases that are particular to Node EOS, so you can use that in your own setup. It's bolted in the dfuse platform as sort of an automatic backup and recovery. It's the fastest solution we have right now. It's faster than doing snapshots of your volume, cost a lot more cost effective because it's deduplicating the chunks of 50 megs everywhere. And you can more easily have backups of your full blocks log, and it's not so heavy to continue because it's not a full-blown backup each time. Okay, hope this is helpful. I mean, it's open source, you can use it. And if you like it, start the repo, go to that dfuse-eos.io, and all part of the solution there. Start that repo. If you have any comments in the Telegram channel, don't hesitate. We're happy to take that. Hope you appreciate it. Okay, I'll see you next time.